All right. One more page of notes, I think. We got a couple more problems that I want to do before we call it a day, or before I call it a day. Let's go ahead and solve. Solve x squared dx plus 2y dy equals 0 with y of 0 equaling 2. Okay, so we're going to go ahead and do a little bit of manipulation. We're going to move the x, or the, doesn't really matter. We're moving one of them to the other side. So 2y dy equals negative x squared dx. Okay, integrating both sides, we get y squared equals negative x cubed over 3 plus a constant. Okay, now we're going to take the square root. Remember, we take the square root inside, the c inside of that square root, right? Then basically, if it's a nonlinear sort of operation, you're going to have to play around with or move the constant with it. So y equals, I'm going to write plus or minus c minus x cubed over 3, the square root of that. Okay, now y plus or minus, we don't really know. Now, because y of 0 equals 2, we know that we're going to be taking the plus. But it's very possible. I mean, I could have given you a minus, right? And then I would have had a minus 1 there. Okay, so it's just as likely, or I mean, it's just as possible. But now we're going to go ahead and plug in 0 here. So when we get 0, so y of 0 equals 2 implies that the square root of c equals 2. So c equals 4. So y as a function of x is going to equal plus the square root of 4 minus x cubed over 3. Okay? And you may be interested in checking. Go ahead and check and see if it satisfies this equation. Well, you have to get it for y. Okay? All right, let's take a look at another. Let's solve dy dt equals 2t cosine squared of y with y of 0 equals pi over 4. All right, so we're going to go ahead and we'll solve this. So first thing we're going to do, dy over cosine squared of y equals 2t dt. Cosine squared in the denominator, remember, is secant squared in the numerator. All right, we're going to integrate both sides. Now remember, you may or may not remember that the derivative of tangent is secant squared of theta plus a constant, which we're going to suck into the other side. So we're going to have tangent of y equals t squared. Remember, we keep the constant on the side of the independent variable. Okay. So y equals the inverse tan of t squared plus c. Okay. Y of 0 is pi over 4. So tan inverse of c is pi over 4. What's the tangent of pi over 4? Tangent of pi over 4 is 1 last I checked. Okay, so y as a function of t is going to be the tan inverse of t squared plus 1. Okay, and this one you can just easily see that if I take the derivative of this with respect to t, okay, I'm going to get 2t cosine squared of y. Okay, you guys are going to make me do it, aren't you? Ah, shit. Okay, I'll do it. So let's take dy dt. Let's just check. Dy dt is going to be, so this is going to be 2t times the derivative of the arctan, right? What's the derivative of arctan? 1 over whatever you're taking. Let me write it out. Why did you guys make me do this one? I did not want to do it. Right? So let me write it as theta prime. Okay. So noting this as the derivative of, I don't need the theta prime here because I'm doing with respect to theta. So the 2t here is the derivative of what's inside the arctan. And then it's going to be times 1 over 1 plus t squared. I hope. Okay. Okay, so now, yes, this is going to work. Y. Remember, our tan inverse is t squared plus 1, right? So y is tan inverse of t squared plus 1. So let's draw out the triangle. Okay, so y is here. Y is the angle. Let me write this as tan of y equals t squared plus 1. T squared plus 1 is opposite over adjacent. So this is going to be 1 plus t squared squared. Cosine of y is then 1 over square root of 1 plus t squared squared. So you can see that this is the cosine squared of y. Okay? All right. That's it for this section. I'll see you guys in the next set of videos.